So for example number 4, I want to preface a couple things. You can have a circle, and then so long as you have any type of polygon, it doesn't matter what type of polygon it is, if the vertices of the polygon are on the circle, then it's what we call inscribed. Oh shoot, it won't fit inside the thing there. I should have drew it bigger. So this is what we call an inscribed. I need another cup of coffee is what I need. Inscribed polygon. Why? Because the vertices of the polygon are on the circle. So this is my circle, and these are the vertices. So the vertices of the polygon are on the circle. Now, I won't prove this next theorem, but I just want you to know that if I have a perfectly drawn circle and I have a triangle, and I have A, B, this is D, this is C, if so, well, let me just, I was gonna write it real formal, but I don't think at the beginning, you guys just don't get the formal stuff right at the beginning, so let's go back. The measure of angle ABC equals 90 degrees, that's this right here, if and only if AC is the diameter. Now, let me translate what that means. If you have a triangle where one of the legs is the diameter and all three vertices of the triangle are inscribed on the circle, then it's a 90-degree triangle, period. That's it. Now, the other thing that we're going to use, for example, because there's two parts to that. So this is what we would call an inscribed right triangle theorem. And then the next thing would be what we call the inscribed polygon theorem. So inscribed polygon. Now, at the very beginning when I started teaching you guys, I said that any polygon could be broken down into a number of triangles. So, and then that's how we prove like the interior angles of a polygon and stuff like that. But here we're just going to talk about quadrilaterals inscribed on a circle. So I have D, E, F, and G, and then the center of the circle is C. So now on this one, they're saying that D, E, F, and G lie on circle C. So that's the first qualifier. If and only if the measure of D plus the measure of E plus the measure of F plus the measure of G equals 360 degrees. Okay? So a quadrilateral can be inscribed on the circle if and only if the opposite angles are supplementary. Okay? Oh, wait. It's not if you add them. If the opposite angles are supplementary. Not plus. In other words, D plus E has to equal 180. Not, I'm screwing up big time. And F plus G have to add up to 180. Okay? I really screwed this up. It has to be the opposite. So it has to be D plus F and E plus G. So that can be reversed, but basically E plus G has to add up to 180. And it doesn't matter what they are, but E plus G has to add up to 180. And then D plus F also has to add up to 180. Okay? So I'm sorry, I kind of goofed that one up because I wrote that thing down, but let's try an actual example and maybe it'll help clarify that. So example number 4 then, I've got a perfectly drawn circle where this is A, this is O, or no, Q, and this is B, and then this is C. And this is 2x. Find x. So this is example 4, part A. So we're asked to find x. Now to find x for this thing, I know that the measure of angle BCA equals 90. I also happen to know that the measure of BCA is also equal to 2x. I know this is equal to 90 because AB goes through the center of the circle, so that's the diameter of the circle, and all 3 vertices, although I didn't draw it exactly like I should have, they're on the circle. Now it doesn't look like 90 degrees because I sketched it by hand. If you look in your book, it looks exactly like 90 degrees. But whenever I have a triangle that all 3 vertices are inscribed on the circle, and one of the legs goes through the center of the circle, that diameter is going to be the hypotenuse of the triangle, and then this corresponding angle here would be a 90-degree angle. But they want us to find x. So I'm going to divide both sides by 2, and I get x equals 45. That's it. That's part A. Now, part B, you have a perfectly drawn circle that looks like this, and I have a quadrilateral. I'm just trying to get this done. So then I say D, E, F, and G, where this is Y, this is X, this is 120, and this is 80. And so we're asked to find D and G. Well, we just look at the opposites. I mean, that's really all we have to do. Oh, I wrote this down wrong. This is not X, this is Z. So then, these have to add up to 360, or they have to equal 180. So D and F, so the measure of angle D plus the measure of angle F have to add up to 180. This is Z plus 80 equals 180. Subtract 80 from both sides. I get Z equals 100 degrees. Measure G plus measure E has to add up to 180. G is Y. plus 120. Subtract 120 from both sides. And I get y is equal to 60 degrees. And that is it.